Okay, this is AS Statistics. We have moved on to Unit 2, so measures of central tendency and spread. These are just very fancy phrases. Measures of central tendency is a fancy way of saying mean, mode and median. And then spread means obviously how spread out the data is. So things like range and interquartile range, which you'll have met before, and then a wee bit on standard deviation, which is by far and away the best way of measuring how spread out things are, although it's complicated to do. So let's look at measures of central tendency first of all. Reasonably straightforward despite all this here. We've looked at graphical ways of representing data. There are several numerical measures we can use to summarize sample data. There are two measures we look at, measures of central tendency and measures of spread. So measures of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the typical or central value. For example, the mean. Everyone wants to know what the class average is, and that's what you're asking for, the mean. The three most common measures are the mean, the median, and the mode. Just very quickly, I won't read all of this. The mode of a set of discrete data is a single value that occurs in most. There may be more than one. For continuous or group data, the modal range is the range with the largest frequency. Easy to calculate, unaffected by extreme values, easy to obtain from a histogram, pie chart, pictogram or line graph. Disadvantages are it's limited in use, one significant if there are relatively high frequencies involved, may be more than one mode, cannot get exact value from group data. Other one then is then median, sometimes known then as Q2, so you know Q1, Q2 and Q3 are the quartiles, and Q2 then is the middle one. The median is the middle value once all the data has been ordered. If the middle lies between two values, we use the mean of these two values. For discrete data, it's a half of n plus 1th term. That'll make sense whenever you think about it. For continuous or group data, Q2 is, sorry you can't quite see that, a half then of the nth term. Again, we'll explain a bit more like that as we go on through. Can be obtained even if some values in the distribution are unknown, less sensitive to extreme values and outliers, that is simply the middle value, unaffected by uneven class widths. For group data, its value can only be estimated from an OGIV, which is the cumulative frequency curve, or a formula, may not be characteristic of data, cannot be used then for further calculations. Final one then is the mean. Mean is often called the average and can be used with both discrete and continuous data. You get used to this as a wee X with a bar over the top of it then as our way of saying the mean. It's the best known, makes use of all the data, can be used for further calculations. We use it then for the standard deviation, which will be coming up soon. It's affected by extreme outliers. Say, for example, you guys all do a test and you all score, about 20 to 25% on it. However, one person scores 95. Then if you work out the mean, that extreme outlier, the person who 95 really kind of sort of wrecks that data, and that's what it's talking about there, because it takes account of all the data. When the data is discrete, it may give an impossible figure, for example 2.4 children. You can't get the exact value then from group data. Alright, other bits and pieces then are just about description. The mean is the sum of all the observations divided by the total number of observations. Mu sometimes used for the population mean and x bar for the sample mean. It can be shown that x bar is an unbiased estimate of mu. This implies that you use the same method for evaluating both. For a list of data we use this. Don't worry about this too much at the minute. We'll come back to it. For a frequency table then we use this. You guys have been working out the mean from a frequency table since year 8 really, so this is just a kind of fancy way of writing with all the theory. For group data you can only estimate the mean, as you know, again you did that in year 10, so you can only find an estimate from the mean because if it's grouped you don't know what all the numbers in each group are by using the midpoint of the classes. This means you assume that all the values in each class interval are equally spaced about the midpoint. A couple of very straightforward examples then just to take a wee look at. And we won't spend too much time on these at all, but just so you can see. Suppose you're negotiating a salary increase for employees at a small firm. The salaries are currently as follows. So they're all between £6,000 and £20,000 apart from obviously the person in charge who's on £100,000. Calculate the mean, median and mode. So I'm not going to worry about this too much. The mean, add them all up, divide by how many there are. You can take my word for it that it's 20,800. The median is 15,000. So you find the middle one. And then the mode which is the most common then as well, is 15,000 as well. For part B, which is the most appropriate measure, if you're trying to negotiate an increase in salary, it's very hard to know, I suppose, but I mean, if you kind of say that the mean is 20,000, that's not a true reflection, and this is the kind of the point we're making. Again, I was talking about the test, so you maybe want to go for the median there, or the mode, probably the median, and that tends to be how we kind of do salaries. If you look up salaries, average UK salary or something like that, it's always the median that they give, because there are very few people who are really, really rich, but they have so much money, those really rich people, that then that mars all the data and kind of puts the mean up way too high. So if you look up data and you're trying to find the average UK salary, the median is actually a much better gauge of it. So we'll write median there, and just kind of for the reasons really that I've said. I hope that makes sense. Which measure may a managing director choose, and why? Well, he might want to choose the mean because it makes it look higher. And then for part D, it says, which measure may a union representative choose and why? And again, someone who works for the union is trying to negotiate an increase, so they're going to pick the lower one, so median then, or mode, and that's the reason then for that. On to example 2. Again, not much. So I mean, mean, median, mode, you've been working them out since year 8, probably since primary school. There's not too much there, but it's just to try to get an idea then of how these numbers work and why they are the numbers that they are. So at A level, you need to be able to kind of manipulate the numbers a bit more, but at the same time have a good understanding of how they work and that sort of thing. Example 2, a company collects feedback on its website. Customers give a score on a scale of 1 to 5 to indicate levels of satisfaction. Here is the data for the first 3 months of a particular year. So the mean was 4.3 out of 370, 3.9 in February out of 280, and 4.2 out of 315. So it says find the mean satisfaction level over the 3-month period. So we just need to multiply up here. So it's going to be January. We're going to do 4.3 times 370, which is 1591. In February, it's 3.9 times 280, which is 1092. And in March, it's 4.2 times 315, and that gives us 1323. If you add those all together, you get 4006. If you add these all together, you will get 965. So to work out then our mean is going to be 4006 divided by 965, and that gives us 4.15.